This video goes with Kuta handout number 19. It's going to demonstrate how to solve equations by first balancing the equation. That means getting variables on one side. So I'm going to do a few examples here. I'm going to start with number one. For some students, if we just draw a dotted line right down the equal sign, and just remember what we're trying to accomplish here. We're trying to get the variables all by themselves on one side of that line so that one side of the equation equals the other side. So I'm trying to find a number to replace r with so that both sides equal each other. So the first thing we need to do is we want to see if we can simplify anything up here. So I say negative 6r plus 1 on the left side of the equation. I see a negative 4r minus 5 on the other side of the equation. I can't really simplify that. So my next step would be, well, why don't we try to move things to get all the r's on one side? So I'm going to do this. I'm going to put a positive 6r here. That's going to move or get rid of this. Do the same thing on the other side of the equation, positive 6r. And I just want to see what happens. So I'm going to put my sum line and just kind of take a look to see what happens here. And when I put a negative 6r and a positive 6r together, they go away. That means I have a positive 1 equals, on this side of the equation, a negative 4r and a positive 6r put together is a positive 2r. And I still have my minus 5. My next step would be, I want to get r all by itself. It happens to be now on the right side of the equation, so when I'm done, I'm going to have r equals my answer. So I got to say, okay, well, how am I going to get r all by itself? I need to get rid of the negative 5 and the coefficient 2 next to the variable r. Let's do the negative 5 first. The opposite of a negative 5 is a positive 5. I'm going to do that over here, positive 5. I'm going to do a sum line again and see what I get. As I look at this, I'm thinking, well, 1 plus 5 is 6, so I'm getting a positive 6 equals, well, a positive 2r, and of course the negative 5, positive 5 cancel. I'm down to my last step. What's the opposite of multiplying by 2? I'll divide by 2, divide by 2. Well, 2 divided by 2 is 1, so there's my 1r. 6 divided by 2 is 3, so r must be 3. That means if I replace the r with 3, I should get both sides of the equation to equal each other. Let me do another example here, problem number 2. So I draw my line down here. I'm looking on each side to see if I can simplify. And on the left-hand side of the equation, it looks like I can put these two things together. So a negative 2m and a positive 8m put together is a positive 6m. And then that equals 6m plus 7. I'm going to see if I can get all my variables on one side. I'm going to move them all over here to the left, so negative 6m and negative 6m, and I'm going to do a sum line just to see what happens here. Put things together, that's what my sum line does, or tells me to do. Positive 6m and a negative 6m put together is 0. A positive 6m and a negative 6m is 0, but I really don't need it over here. The only thing I have left is a positive 7. And I'm saying to myself, wait a minute, what is this trying to tell me in math? 0 does not equal 7. So what are they trying to tell me? Anytime you see this, what it's trying to say mathematically is there is no solution. So anytime the variables disappear, usually you're going to get two numbers. And if those numbers do not equal each other, mathematically we're trying to say no solution. I'm going to do a couple more problems. I think I'll go farther down onto the handout. I'm going to look at problem number 5. When I look at problem number 5, the one thing I notice is that both sides look identical. This is called an identity in math. And when I see an identity in math, then I'm thinking both sides look exactly the same. That means that all numbers are solutions. It doesn't matter what number I pick, it will work. And my last example I'm going to do is going to be problem number 6. I'm going to go ahead and put a line down here. And before I get started, I'm going to see if I can simplify. Looks like I can put a negative 11 and a negative 1 together. Looks like I can also put a positive b and a positive b together. So let's just kind of simplify things. When I put a negative 11, negative 1, I get a negative 12. When I put a positive b, I get a positive 2b. All of this equals, and on the other side I can't simplify, so b minus 6. I think I'm going to do this. I think I'm going to do a negative b over here to get this to go away. Try to balance the equation, get all the variables on one side, so negative b here. Let's see what happens when I do my sum line. Well, let's see, a negative 12 and nothing is a negative 12. Positive 2b, negative 1b put together is just a positive b equals, well, positive b, negative b go away. I have a negative 6 on this side of the equation. I want to try to get b all by itself, so that means I have to get rid of the negative 12. What is the opposite of a negative 12? Well, a positive 12. Need to do the same thing on this side of the equation. And as I simplify again by putting my sum line, looks to me like a negative 12, positive 12 cancel. Positive b and nothing, there's my positive b. Negative 6 and a positive 12 put together is a positive 6. Hopefully these examples will help you with tonight's homework.